Log on, tune in, find out. Another good idea from Cambridge.
Well, it's now a very great pleasure to introduce Professor Calvin DeWitt. He is Professor of Environmental Science at the University of Wisconsin-Madison and President Emeritus of the Au Institute. And he has prepared hundreds of students for environmental careers, helping them to improve their environmental beliefs and inspiring them to reach out to help people incorporate environmental integrity into their world views. I think a theme that's been raised from the floor, as it were, as a vital concern. So he's written numerous papers and has become a pioneer through his lectures and papers in the US for environmental concern and raising awareness thereof. So, Cal, over to you.
This afternoon, I'll be dealing with this subject, sifting and winnowing for the truth, climate change in an age of deception. I should say, as background here, that I have held political office in America, and as well as maintain simultaneously my position with the University of Wisconsin, which is a great challenge to do. But the importance, I think, of that for me is that I've confronted some of the very issues that we often deal with academically, but I've dealt with them very practically. I've been in situations where I certainly would have been more easily I would be much easier just accommodating to the pressures, to the influences, to monetary gains that one could get if you sacrificed your values. And I was able to hold true to that largely because of my faith. And from that, I realize more perhaps than most that deception is one of the components of the political world and the social world and the business world. This year is the 400th anniversary of the birth of John Milton. It's being celebrated here at Cambridge University, and I think it's a very important anniversary because John Milton had a great deal to say about the similarity between good and evil. And he had a great deal to say about seeking the truth. And I'll give some references to him and his writings here today in my presentation that will link us way back to that time when he was present here in England. Oops. Sorry, this is not part of my program.
We need a technician.
No, I think we're okay. Yeah. You see, that's the very last slide, and it's outside of my lecture completely. Yeah, here we are. And there we go. This should work. Yeah, it does. So what I'm going to do here with you as part of our mutual education is I'm going to take some of the points that Sir John Houghton brought to you yesterday evening, and I will broaden out some of these things, particularly where they relate to seeking for the truth. There is, as you know from his presentation, a series of 4 books, 4 reports. They're very extensive, and these are reports of the Intergovernmental Panel on Climate Change. And Sir John chaired the scientific assessment group that produced this book, and this book, at approximately 5-year intervals. The current one that was published just recently in 2007, again, he had a great deal of influence on, but at that point he had moved to the side to let someone else take charge of this immense process. The process of work by the Intergovernmental Panel on Climate Change was the result of a joint effort between the World Meteorological Organization and the United Nations Environmental Program. It was the first great assembly of scientists dealing with a global issue. I'll show you another such assembly as we're getting into the talk a little bit further. But it's important for us to realize that we have 1990, 95, 2001, and 2007 reports. And you'll be real interested to know that during the course of those 4 reports, this is the temperature data. I'll give it to you in more detail in just a moment. But here's the first report. This is first assessment report, second assessment report, third, and this is the 4th report, these 4 vertical lines. And you can see what is happening at these approximately 5-year intervals is the Earth is getting warmer. That's making it more helpful to the IPCC, of course, but there's something else that's happening during that sequence of reports. And the thing that's happening here is that FAR, SAR, this is first, second, third, and fourth. What's happening is that in the climate modeling process, as is true for other kinds of modeling of geographic space, what's done is to conceptually carve up the world into long cylinders or long prisms. They're vertical bars of rectangles or squares. They're square prisms usually. And you can see what I've done here is for where we are right now here in England, I put up here a diagram of what the resolution was of that first set of models that we used. And you can see that the squares up here, which are the tops of these large pillars, are progressively getting smaller as they're moving from here to here to here to here. In other words, the resolution of the models has increased. Now, what is done with these models? What's done with these models is that they are cut up into layers. This layer, this one, for example, has 26 different layers in it. And what is done is equations are written for the movement of various things, gases, chemical substances, air, and so forth. Equations are written that describe the movement of those substances to the north, to the south, to the east, and to the west. In other words, and what happens here is that you partition the entire world up into these cells, they're called, and then at 26 different levels, which we're doing here, you compute the movement of materials as driven by various factors such as solar radiation input to the Earth, currents, and so forth. So the problem in moving from here to here is the computers have to get bigger and bigger and bigger, and these iterations, these calculations are not just done once, but they're done time and time and time and time again, and of course only the largest computers available can do this work. Interestingly, this model, AR4, is available right on the internet. It has a PowerPoint that you can use to learn how to use it, except your computer is not big enough. It's really very exciting just to think that this is public information. You can actually download the model, and if you're one of the people who are interested in actually working with the data, which of course none of the critics are, then you can take the model and actually work with it. It's a marvelous thing. What I've done is I've taken this one then and just expanded it so we can see our place here in England and in the world. And I hope that gives you some kind of sense of the texture of the model. Models, of course, are that. They're simply a model or a representation of the real world. And the closer and closer we got our representations to match the real world, the more detail we can deal with. But of course, we also get into problems of running it at a high enough speed. I've done this kind of model for wetland development in Wisconsin, and what we do there is we develop these cells, these vertical cells, and then write the equations for the movement of peat from cell to cell as the peat is deposited by decaying plants above. And when we first ran this model on the university computer, we had to run it at 3:30 in the morning and get everyone else off the computer because we had to use the entire University of Wisconsin computing system just to run this one model. That'll give you some idea of the kind of the technical challenge of doing modeling. Well, when we went from F first to second to third to fourth, not only did the resolution of the model increase, but also the components. So we moved from here to this one and this second one. We put in volcanic activity, sulfates from stacks, many other things. Here, aerosols were introduced. We also introduced into this model the turnover circulation of the oceans. We incorporated all the major rivers of the world. I say we, referencing the whole human race, rather than because it's kind of this big joint activity. And then in this one, the one that is now the basis for the 2007 report, atmospheric chemistry is included, the vegetation is included interactively with everything else, soil building, CO2 consumption, oxygen production. The consequence of this work for 2007 is this slide, which Sir John presented at the Nobel News Conference. I've got a series of slides. I don't know if he showed. I don't think he showed them. I don't know if he's lost them, but I called up the Nobel site and was able to find his presentation. And this is one of his presentations. This is the first slide and the conclusion. And of course, it's written this way in the report. Warming is unequivocal. So what you know from everything you heard so far is that the IPCC is extremely measured in its assessment of things. They use probability statements, very likely, possibly, and so forth. This is rather dramatic because this very reserved, pretty conservative group of scientists is saying in this report, warming is unequivocal. This is just a summary of some data which gives you error bars along with the actual data. These are measurements, all of them, from thermometers, beginning shortly after 1860. All the data here are from thermometers, and it still is a problem because how do you measure? It's kind of like throwing, this is what I picture it, is having a swimming pool and pouring in a kettle of boiling water and saying, did it warm up? And the answer is yes. And then if someone says, prove it, you've got a problem. Like, where do you measure that? Do you consider mixing, so on? So anyway, it's very hard to do these measurements actually, and it takes a great deal of statistical work, and so get this, but here are the data from some authors. Now, Sir John, in his presentation, just smoothed out this whole curve and put this as a temperature anomaly like this, because after all, these were the Scandinavian royalty who were listening, and they didn't want to be confused by too much data, and so this has been smoothed out. And this is the temperature anomaly, and I think it's very interesting because what was done was to run the model without using any human anthropogenic contributions to the atmosphere. So this is a model using only natural forcings. Now that's pretending like human beings don't exist on Earth. It's pretending that there's no industrial carbon dioxide production, that things are operating without our presence. And when we put into the model the human presence and CO2 production, then our curve becomes the pink curve, and you can see it matches. And so what the IPCC says is probably we're important here. It was interesting, one of the things that is kind of troubling to me sometimes is that we have to be so measured in our responses to what we see in the world. I have in my backyard right now a mother and father sandhill crane with their chick. They've hatched, it's hatched from an egg just about 1,000 feet from my house, and I'm very excited about that. If I were to report on this scientifically, it would look very bland, but it's not the way I feel. The way I feel is great wonder. And what will happen is, let's say if I publish it, the sandhill crane population will go up by one bird, and you might have to say whether that's significant or not. So sometimes as scientists, when we report things in the literature, we can't be very excited. That's just part of the discipline. And I think the thing that's interesting for me is I'm really very excited about the beauty of creation, the beauty of the world, and most every scientist is. But we're mainly not poets in our writing. Well, I said I was going to come to another major grouping of scientists, and this is a group that was formed by the Secretary General of the United Nations in 2001. They worked for through to 2005. This is called the Millennium Ecosystem Assessment. Extremely important, absolutely important, because for the first time, I think it's 1,543 people, you can write it down, kind of 1,500 scientists, about 1,500 scientists, oh, here it is, 1,360 experts from 95 countries. These are scientists from 95 countries. 1,360 made the first effort by the scientific community to describe and evaluate the services provided on a global scale by nature. In theology, if we go back to the time of John Milton, whose birthday we're celebrating this year, what you'll discover is the idea of ecosystem services was already present. It was present here at Cambridge and at Oxford and in London, in the House of Lords and the House of Commons, but it was expressed as God's providence. And God's providence were the great gifts that God gave both to the human species, but also to every aspect of creation. And this was the air we breathe and the sea in which organisms live. So what we've done over these 400 years, and particularly in the last 10, is we've begun to reinsert this idea of providence, but we're doing this using a new term. And the new term that's being used is ecosystem service. This was met with some questioning early, because if you're being served by something, doesn't the server have to have knowledge of its service? You know, those are the sorts of questions you ask academically. Can you be served by something who doesn't know they're serving you? And is this really service? Well, all those arguments are more or less past us now because of the need to somehow express what's happening. I work much in wetland science, and one of the things I know from this research and study is that wetlands, especially wetlands that are bordering our streams, are immensely important in the area of preserving lands from flooding or minimizing flood flow because they absorb a great deal of water. And then during drought flow, they continually feed water back into the river. And so it keeps drought flow high, and it minimizes flood peaks. And wetlands are very important. But what's been done here in England and what's been done along the Mississippi River and so many other rivers of the world is that these wetlands that have bordered our streams are steadily filled, drained, encroached upon by agriculture, and many of our cities, of course, have been built right in these areas. And we're discovering, of course, that these services that the floodplain wetlands have given us have been actually absolutely vital to us. The United States Army has a division called the U.S. Army Corps of Engineers. And what they did, starting a little after 100 years ago, is one of the big rivers of Florida, the Kissimmee River, they put into a straight channel. They got rid of the wetlands. The idea was, let's get this water to the sea as fast as we can. What they've been doing for about the last 15 years is rebuilding all the meanders into the stream. And the reason is we have discovered that one of the services of a river, which meanders, is to diminish the force, the energy of the stream. And if you want to think of it in terms of a service, think of what's happening if you have to pick up the bottom of the river, deposit on this bank, and then pick it up again and deposit it on this bank. That's what's happening in these meanders, because these meanders move through time, and the way they're working is they're cutting into steep banks, they're mobilizing soil, they're depositing it into a quieter bend, and this continues. And now we're doing things like computing how much it would take energetically to transport all this by truck. We discovered then that rivers have a certain character to them that diminishes their energy. And it seems like that is one of the functions of the meanders. And then the wetlands are also being restored by the Army Corps, because we want the river to continue to flow during periods of drought, and we don't want it to flow over its banks, or at least not very far, during periods of flood. So those are examples of ecosystem services, some of which we have not really understood until recent years. So they assess the consequences of ecosystem change for human well-being and to establish a scientific basis for actions needed to enhance the conservation and sustainable use of ecosystems and their contributions to human well-being. I think you'll find really exciting what I have to say tomorrow about conservice, a biblical principle of conservation, and it relates to this ecosystem service, and that's one connection I'll make just for the moment. The Millennium Assessment Board, the board that administers the entire 1,360 scientists, made this statement in 2005 at the conclusion of the report. This is a very significant conclusion because we have never had any conclusion like this drawn before, not by the IPCC either. The conclusion is human activity is putting such strain on the natural functions of Earth that the ability of the planet's ecosystems to sustain future generations can no longer be taken for for granted. We have been able to take for granted these ecosystem services for a long, long period of human history. Protection of these assets can no longer be seen as an optional extra to be considered once more pressing concerns, such as wealth creation or national security, have been dealt with. Healthy ecosystems are central to the aspirations of humankind. What is an ecosystem? An ecosystem is the biotic component and the physical all interrelated. And an ecosystem is this set of harmonious, ordered, interacting organisms and their physical environment that more or less can be distinguished from other such systems that rest alongside it and around the world. For example, a riverine wetland is an ecosystem. The river itself might be considered to be another ecosystem. A prairie is an ecosystem. A meadow or a set of meadows would be an ecosystem, in which case it's a human related ecosystem. And the boreal forest is an ecosystem, and so forth. We can go on and on and on. And if you apply this term ecosystem very technically, you can discover very tiny ecosystems. Like one of the things I have admired, which perhaps none of you share with me in this admiration, but it's a rotten spot on the surface of an orange. And on the surface of the orange, you've probably noticed there's kind of a green color if it's getting rotten. That's Penicillium notatum, which is the bacterium in culture from which we get penicillin. And then associated with it is a whole bunch of other organisms, and its physical environment is the skin of the orange. Technically, that's an ecosystem. But mostly what we're thinking of when we're thinking of ecosystems are fairly big things. You know, maybe 50 square miles or maybe a square mile or a square kilometer or 10 square kilometers, something like that. But it's defined not by the area, but by the boundaries that you can discover more or less that separate it from the systems around it. If we take systems thinking, which is basic to ecosystems study, we can look at the body as a kind of metaphorical example of systems. In fact, we have the digestive system, right? And you can distinguish the digestive system over against the skeletal system. And similarly, if you look at the human eye, although we don't look at that as one of the major systems, the human eye is a system because you can distinguish it from the systems around it. If you have half an eye, that's not a system. In other words, what you can do quite quantitatively and richly qualitatively is you can distinguish system from system. So these ecosystem services are coming from these various ecosystems, and they give different kinds of services. Now I'm going to shift our thinking quite a bit because we're moving toward the topic of climate change in an age of deception. And I want you to look at enterprise in the 21st century. It really, of course, is enterprise as it's developing in the 20th century as well. But what we see here is a globalization of the human economy. It used to be that we could think about the economy of China as independent of the economy of Afghanistan or of Nigeria. But that's really no longer the case. It is globalizing, no matter whether we like that or not. And it has various causes. But that's one of the things that we are experiencing. Second, we're experiencing the disruption of the biosphere economy. It is interesting that when Linnaeus, Carolus Linnaeus, who is the great Swedish taxonomist in 1658 wrote Systema Naturae, the basis for scientific classification. He wrote an essay on the economy, and interestingly, he defined the economy as the remarkable system whereby God matches ends and means in its governance of creation. Economy has a bigger word than just money, and you can really speak of the economy of the biosphere. What the biosphere has are these ecosystems, all of which play some sort of role in a larger system, and that larger system is referred to as the biosphere. The biosphere also is a biblical term. It is called oikomene in Psalm 24. The earth is the Lord's, G-E in the Septuagint, and its fullness. The world and all who dwell in it, the oikomene, and all who live in it. The oikomene is another way of saying biosphere. We also see, number 3, that enterprise in the 21st century is largely characterized by the fragmentation of education into specialties. Yesterday and the day before, we had a writer's workshop, and one person's the economist, the other one is a volcanologist, and another one is an atmospheric physicist, and these are the specialties whereby we identify ourselves. And if you're here a professor or a student at Cambridge University and say, what is your field? You won't say, you might say, but doubtfully it would be said natural philosophy. You'll say, oh, I'm a biologist, marine biologist, a physicist, a historian, philosopher, and so on. We have fragmented our education into specialties. Some of this fragmentation goes way back, but what has happened in recent times is that fragmentation has become even itself fragmented. When you come into the University of Wisconsin and you're going to do a PhD in chemistry, for example, you have to choose between 7 different fields of chemistry. You cannot get a PhD in chemistry. It has to be physical chemistry, organic chemistry, analytical chemistry. We're carving up things smaller and smaller. And our university has 18 different departments of biology, none of which cover biology, but just a piece of biology. So we invented something recently for undergraduates which is considered to be extremely innovative. We've developed a biology major, which is an attempt to pull it all back together for the undergraduate. Interesting, isn't it? But the most important thing is that we have a corresponding fragmentation in business and government. We're trained at Cambridge, we're trained at Yale, we're trained at Wisconsin, and our businesses hire an economist, or a systems engineer, or an artificial intelligence computer scientist. And we fragmented that, and one of the consequences of this is that we tend, even there, to become specialized. So ExxonMobil, for example, considers itself to be a petroleum company. BP, interestingly, has considered itself to be British Petroleum for a long time, and it has discovered, I'm not sure how it discovered this, but it discovered that it's in the energy business. Not the petroleum business, but the energy business. And so BP now means beyond petroleum, and I think they're now the 5th largest producer of solar panels. You won't find ExxonMobil producing solar panels because that's not what it is, right? And this reflects a lot of the disciplinary fragmentation. It'd be interesting to look at who's the president of BP, and maybe he did major in natural philosophy or theology. I should, just as a parenthesis here, I visited a farmer once in Nebraska who had this tremendously integrated farm. He not only had an integrated farm, he was growing all sorts of crops. he was extremely wealthy. You could tell that just by the way he was managing things. But his storehouse also had sesame seeds in it. And I asked, how'd you get that? And he said, well, in order to market the diversity of my produce, I have to sell sesame seeds along it, and I import those from Lebanon. And we mainly bring these to university towns where people are sensitive about what they're eating. And we give them this package of all these different foods, most of which I grow here. And I said, what kind of background do you have to do this kind of work? This is very exciting. He said, seminary. That's what he had done. He had gone to seminary to become a farmer. Now, that's not too far-fetched, because a seminar is a seed bed. A seminary is a place where there are lots of seminars, lots of seed beds, and they plant seeds all the time, and they produce pastors who lead sheep. So seminary is a very good place to be as preparation for a farmer. But agronomy, forget it. Because you'll be thinking only of production. And there's a lot more to farming than just production. It's an important part, of course, extremely important. But when all the drinking cups for your cows freeze in the barn, which they did for one of my local farmers, you have to be more than an agronomist, or all your cows will die. Corresponding fragmentation of international law. And this is really kind of coming right down to it. I'm not sure what we're going to do with this discovery. But when we go back, again, almost about 400 years, to the time of Hugo Grotius and the time when there was a great deal of international trade growing across the seas, the idea was that national laws covered the nations, but they did not cover the seas. And so what was becoming fairly common was that if you came upon a ship that originated in another country on the high seas, you could take it. They could take you, because there was no law governing the seas. So Hugo Grotius, at the time of this great expansion of the Netherlands' influence through international trade, wrote what is called the law of the sea. And it has been in effect until early into the 20th century, and in fact is still right at the core of international law. And interestingly, Grotius, Hugo van Groot was his Dutch name, and Hugo Grotius, his Latinized name, was both a theologian and a jurist. And what has happened is that theologians are no longer employed by law schools. Can you imagine that? And also, if you are a lawyer, you probably won't get a joint degree in theology. But it was the case. And what has happened is we have now gone through a transition of going from courts of justice to courts of law. So you probably have had this experience already. Someone of yours saying, that just isn't right. And someone said, but it was legal. And so what we in time have discovered is we've created courts of law from courts of justice, and we've done that largely by removing some of the ethical moral constraints that were present. We have gone largely toward using rational thought and natural law to establish the current body law, and of course part of natural law has been strongly influenced by the 1859 publication here in England, The Origin of Species by Means of Natural Selection by Charles Darwin. That has become our understanding of how the world works. What is legal versus what is right? And now we come to John Milton. I normally wouldn't have brought him up, but this is his birthday. I'm not sure it's appropriate to sing happy birthday or to have a cake with 400 candles. But this statement is the first statement. I'll read the second one, which is much more direct. Where there is much desire to learn, which is the case here. It's the case here amongst this class. It's the case at Cambridge University. There of necessity will be much arguing, much writing, many opinions. For opinion in good men and women is but knowledge in the making. A little generous prudence, a little forbearance of one another, and some grain of charity might win all these diligences to join and unite in one general and brotherly search after truth. It's interesting that he would say this, because that's really what a university is about. That's what this class is about. This is really what the world is about too, is we can disagree, we can argue, but that shows we're alive, but we're really all seeking truth. We're not trying to get our way, we're seeking truth, according to Milton. And this, I think, is especially relevant, and that is good and evil, we know in the field of this world, grow up together almost inseparably. This is really a prescient thought, insight. Good and evil, we know in the field of this world, grow up together almost inseparably. And the knowledge of good is so involved and interwoven with the knowledge of evil in so many cunning resemblances, hardly to be discerned. The sentence goes on. I should have 3 dots there. So over these last couple of days, we've been working together with a group of scientists and ethicists and economists to write a book called The Roots of Unsustainability. And what's interesting is what would happen is someone would present something which was clearly a good, and then someone else would counter it with another good, which the first person would look at like it was evil. I mean, it's like we couldn't agree on what was good and what was evil. Like, just say, what is your view of the market? Well, you can't say, right? Because you've seen the market really used for evil. You've seen the market really used for good. And so, another thing Milton writes is, you know, if you're discussing this, then you're alive, and that's good. But if you stop discussing it and you just say, I'm a market economist, you're dead. Because you have to keep discussing it. And as you discuss it, what you find, and if you discuss it with others, you find that you're in the truth-seeking mode. At least if you have these characteristics of, which we saw in the previous slide, of generous prudence, a little forbearance, and some grain of charity. And at the University of Wisconsin, on our main building called Bascom Hall, we have this plaque. It's cast in bronze. One of the things that people say sometimes, well, that's not cast in bronze, or that's not carved in stone. We have a couple of things on our campus that are actually cast in this way, and so this is important. Whatever may be the limitations which trammel inquiry elsewhere, we believe that the great State University of Wisconsin should ever encourage that continual and fearless sifting and winnowing in which alone the truth can be found. Continually sifting and winnowing. And interestingly, cast in or carved in stone nearby is the statement right near this one. Let us have faith that right makes might, and in that faith, dare to do our duty. Interesting. Truth-seeking is really critical. Now I'm going to get to truth-seeking on climate change. And first of all, we have the IPCC that produced these reports. We have hundreds of scientists together, and we're working very much in the direction of understanding the world. We can't do that immediately because our models don't have a high resolution, but we can move in that direction. And then we work to make the models better and so forth. And eventually we come in 2007 to say that global warming is unequivocal. One of the ways that that is done in the scientific world is to make sure that we publish our results only in peer-reviewed publications. Peer-reviewed means that what we've studied will be subjected to 3 referees who are in the same field, and if they agree that you've used the right methods, you have sufficient data, and so they will recommend to the editor of that journal that it be published. There's a second kind of recommendation, and that is publish with revisions, and there's a third, reject. And I've gotten many rejections. I've got many in the middle category, published with revisions. I have a key paper of mine that got published with revisions 7 times, and I resubmitted it every time. And finally it was published, because what was happening in this was I was changing the way we were looking at a whole ecosystem. And science is very conservative. It doesn't like to change its old models. And so you have to keep at it. Now, another way you can work in science is when you get a rejection, and then another rejection, you just start to lip off. You know, they're bad, and so on. That's part of the problem, but it's not all of the problem. I have felt that way too. I know I'm right, and this guy, these 3 guys, but what you have to do with your 3 referees is write a nice letter back covering all their points, giving more data, saying, I'll do this in the paper, and so on. What you're doing is you're extending your education from your work in graduate school now to being educated by your colleagues. And if they're wrong, you have to educate them. That's what the academic community is about. That's what referees are about. Referees are also people you can teach. But if it's not clear to them why you're saying what you're doing, then you're not going to publish it. So that is first and foremost the great filter that prevents unreasoned or less than adequate research from getting published. And so IPCC has used only refereed literature. And even that they've looked at very critically. So we come to Naomi Oreskes, who's a professor at the University of California, Berkeley, who in the year 2004 wrote this essay in Science called Beyond the Ivory Tower, and this is really the key part of the subtitle, The Scientific Consensus on Climate Change. Now remember, this is 2004, and what she did was she worked for the period of 1993 to 2003. Many of you have used the internet, Google search and so forth. There is what's called on the internet, available on the internet, the ISI database. If you're a scientist, you'll know about that because it used to be called Citations Index, and what it does is it references all the papers, it lists all the papers from about 15,000 journals. 15,000 journals, not just which are publishing 4 times a year, or 12 times a year, or twice a year. And what it does is it tracks not only every journal article that's been published, but who cites it. So it forms this tremendous network. So if I've written a paper, I can call up my paper and I can find out who has cited my paper. And you can do this year after year, and you can get an idea of what your community is and what they're saying about your paper. So the ISI database is a very important database. It's the most comprehensive one we've got. And so what Naomi Oreskes did was she called up the database, and you can, just as on Google, you can put in quotes any term. And what she did, she thought through this very carefully. What she did, very thoughtfully, is she'd only put in the words climate change, nothing else. And then she'd find out how many papers would come up. And she found 928 to come up. Now, how many papers had been published? Thousands, probably. But some would be in the New York Times, the London Times, trade journals like EPA from US, and so on. Those don't come up because none of them are refereed. And also any journals that are not part of ISI search, which is 15,000, it's very many, won't be in there either. So it's a sample. So she found 928, and what she did is she classified them into one of 6 categories. She looked at the abstract only. She didn't read the papers. She looked at the abstract. And number 1 was, category was explicit endorsement of the consensus position. That's the IPCC position. Explicit. Secondly, evaluation of impacts, which is implicit endorsement, because when you deal with evaluation of the impacts, you're doing so out of the consensus view that there really is something that's going to make an impact. And then third category is mitigation proposals, like how are we going to deal with what's coming. And she found that 75% of all these abstracts fell into these first 3 categories. And then the 4th category is methods, like how do you build these models? That's kind of like I was showing you here in these pictures. And how do you make the measurements of temperature and gases and so on. The 5th is paleoclimate analysis. And one of my colleagues, John Kutzbach, does this very extensively. What he does is he takes historical weather and climate records from the past and he predicts the present. It's a very powerful way to hone your model. Is you take the data from the past, which you can get from ice cores, tree rings, and so forth, and you run your models only to the present, and you predict the present. And if it doesn't turn out right, you can really look at it. And then you change your model until you're predicting the present properly. So that 5th category is paleoclimatic analysis. And the 6th category is rejection of the consensus position. What she discovered was 75% fell in the first 3, 25% dealt with methods or paleoclimate, and 0% were found in the last category. You can imagine that this article got all sorts of flack. Well, at least if you know what's happening in the US. There was one article that cited a whole string of articles that she missed. And so I laboriously went to all those articles, I read all their abstracts, and the objector didn't have a case. Except that it took an awful lot of work just to say that the objector didn't have a case. And then I just read today on Google search someone who said there are, like 12,000 articles and she only hit 983. And I think, well, that's true. But look at her method, and So, in any case, Naomi Oreskes, 2004, it's in Science, volume 306, page 1686. Now we come to one of the people who just left this morning. I came into breakfast and he was sitting with John Houghton, and in about 5 minutes they were leaving. Jim McCarthy and John Houghton both worked with the IPCC. Both shared in the receiving of the Nobel Prize for this work. And Jim McCarthy is the current president of the American Association for the Advancement of Science. He's a biological oceanographer at Harvard University, and he has the Alexander Agassiz Chair he holds that chair there. He's very distinguished, and he's been working on climate change, particularly as it interfaces with the sea. And he and another colleague of mine, James Hansen, in particular, who works for NASA, have been confronted very strongly by people who are saying this whole climate thing is just a big farce. And so the Congress invited Jim McCarthy to appear there to give testimony. And I was happy to be able to pick up the whole testimony. You can do that easily on the web if you want to find it. But he spoke here. He spoke here on the 25th. He also was part of our workshop. And one of the things that disappointed me in his presentation, although there's very good reason for it, is he didn't read right from his testimony to the Congress. He was doing like every good academic does, and he was presenting his findings in quiet tones that wasn't going to upset very many people. When he's in the U.S. Congress, this is what he said. It is now clear that for a number of years, both the Bush administration political appointees and a network of organizations funded by the world's largest private energy company, ExxonMobil, have sought to distort, manipulate, and suppress climate science so as to confuse the American public about the reality and urgency of the global warming problem, and thus forestall a strong policy response. That's pretty powerful. This is for the record. You know, you're sworn to tell the truth when you're giving this record. This is very, very important. And of course, it corresponds with everything we know. But it's not very wise to say it. And the reason it's not very wise to say it is you then will start to receive the flack. And of course, he has received a great deal of flack for this. One of the things I've done is I've put climate change in quotes, like Naomi Oreskes has, but doing this on Google, and then ExxonMobil. And I did this a couple of years ago, and I found 30-some agencies and organizations that were funded for climate change, and not one of them was a scientific organization, which is interesting. There are think tanks, conservative think tanks. And then another thing I should tell you is I got a letter at one point offering me $10,000 to write a paper in opposition to climate change. And just write what you want, and we'll decide whether it's publishable. I think it's somebody who took this offer, whose paper was written against climate change. I received a copy, as every scientist in America did, in my mailbox. It was against climate change, and it was published in the American Journal of Anatomy, a refereed journal. You have to think about that. So one thing we have forgotten sometimes to say is publishing in the refereed literature should be in approximately the same field as your research. So even this, for me, is difficult to relate to you. You know, if I would just relate to you some of my own direct experiences, I feel bad. But it's very, very nice to take this testimony, a sworn testimony before the Congress by one of our leading scientists and say, here's what he says, and you can call it up. A good way to find it, actually, is just to take a few of these words on Google, and you'll come right to the testimony. It'll be easier than looking up U.S. Congress. They have written many other things. And here's his continuing testimony. Unfortunately, these efforts have misled many individuals, including elected officials, to believe that the human influences on climate change are either negligible or of little consequence. I think this is true. The science, however, leaves no doubt that human-induced climate change is of enormous potential consequence and clearly one of the most urgent issues of our times. And then, it is also increasingly clear that we only have a narrow window of time, a decade or less, within which to initiate serious action if we are to avoid the highly negative impacts of global warming that are otherwise projected for this century. Powerful. Now we come back to Milton's statement about these. Remember that one? It's an interesting one. Yeah, this is it. Where there is much desire to learn. And that's, I recall Al Gore being interviewed on our National Public Radio about a year ago, and he was being interviewed on his film, The Inconvenient Truth, and the interviewer said, what's your greatest concern about President Bush? And Al Gore said that he's not curious. And I thought about that because, I mean, it's a rather deep insight. It's not a political slang or anything like that. He's not curious. Well, that's the kind of student I don't want to have. Is the student's not curious. And so when I'm with them in the wetland, I cross a creek. And they're sinking in the creek because they're not curious, and finally they'll say, yeah, now what is that, Pete, again? And you try to enlist their curiosity, and what that really has to do with your passion to learn. And that's what we have to all have, is a passion to learn. So where there is much desire to learn, there of necessity will be much arguing, much writing, many opinions. For opinion in good men is but knowledge in the making. It's a nice quote. Let's see, I saw that somewhere recently. Oh yes. This is a brochure produced by Cambridge University. And it's for the 18th Alumni Weekend. University of Cambridge, 800 years, 1209 to 2009. And this is celebrating Milton's birth 400 years ago. And here they say underneath this beautiful, beautiful cephalopod, where there is much desire to learn, there of necessity will be much arguing, much writing, many opinions. For opinion in good men is but knowledge in the making. Well said, Mr. Milton. And a great university also has then repeated it, which is good. We're coming to the conclusion. What I do in my work, and I'll probably refer to this again tomorrow, But what I do in my work with all my students, in practically every lecture I give them what I call the science, ethics, praxis triad. And this is really putting some of this into a framework of thought. Science, or ciencia, which really means all of knowledge, deals with the question, how does the world work? We're very interested in that. Most of our universities spend most of their time there. The other corner, ethics, what ought to be, is something that we often don't deal with within at least the scientifically based universities, the ones that are looking at natural science. It might be relegated to theology, it might be relegated to philosophy, and it also might be relegated to the history of ethics rather than how one behaves. But it was true in American education at the college and university level for a good 150 years that the last course taught was in moral philosophy for all students. And then praxis, then what must we do? And what's important to realize is if we know how the world works and then we go right away to practice it, we can get into lots of trouble. And that's what I think we have enabled ourselves to do by excising morality and theology from law. It is also something that we have been enabled to do by fractionating the disciplines. Because we can say, I'm a physicist, I know E equals mc squared, we can make a bomb, and we'll do it here. And what we have to be doing, even though we live in this world that's continually reducing things to more and more manageable size, we have to somehow come up this ladder of organization to hold all three corners of our science, ethics, praxis triad together. The way I like to think of this is in terms of religating that which has been torn. A ligament is a piece of connective tissue. It's really more than a piece of connective tissue. It's elaborately beautiful connective tissue that binds bone to bone. We call those ligaments. When you have surgery and you tie off an artery as you're doing work elsewhere, that's called a ligation, which is a ligament as well. What religio is, at least by one definition, is a religation of what has been cut asunder. And so what I'm suggesting is religion for the world's purposes, at the very broadest level, is religating science, or scientia, ethics, and praxis. Putting back together a world that has been cut asunder in such a way that we can live whole, and in such a way that, in fact, we can, again, live rightly on the earth, not just a few of us, but all of us, and so that we can spread right living.
Any questions? Back, yes?
When did this balance break down? Or did it ever exist?
It did exist. It's more like, well, I can tell you how it happened in America. And it happened differently here in England and the UK. In America, when the European settlement took place, there was a tremendous belief by the leaders that the education they were leaving in Europe had to be reinstated here for students so that they could live a full orb life and so that they would be rich in their intellectual history. And so colleges were established. They were about 96% of those colleges were established as Christian colleges. And the state colleges, like the University of Wisconsin and the University of Michigan, were still administered by a pastor or minister. So those were religious as well. And they were confined to about 200 students, and all the students took the same courses, and they capstoned the experience with moral philosophy, which was then, how rightly do you live? It was Henry Tappan in the mid-1800s at the University of Michigan who saw a tremendous disjunct between the education Americans were getting and the needs of the society. For example, lawyers were getting their education as apprentices of other lawyers, and doctors were getting their education as apprentices to other doctors, rather than being taught in the university. There was no university. There were none. And what happened was the theological schools were the first thing that was the closest to the university. But these colleges were liberal arts colleges. They taught Latin, Greek, the great books, the philosophers, in order to become fully educated. So what Henry Tappan did was to introduce specialization and the disciplines. And it went a little ways, and then he got in trouble with his Board of Regents and got fired for trying to do this. He was a pastor too. But the idea caught on, and what happened was the advantages of having a larger faculty were soon seen, because these small colleges could just have a handful of faculty because they only had 200 students. And this was a way to have lots of faculty, and that added to prestige. But it also brought these universities to be able to more directly serve the society through medical schools, law schools, and all sorts of other specialties. This worked very well for quite a time, and that's historically recorded as well, because people would maintain a liberal arts core, and then they would have these various majors. And then what happened was that the disciplines began, some of them, not all, none in the sciences, but in some fields, they began to develop their own terminology, and they began to talk as though the only truth came from that discipline. And we can't talk across disciplines. And eventually we came to question whether there was truth at all. So the discipline structure became, the disciplinary fragmentation, and this is well documented historically too, became, especially in humanities and some of the social sciences, as disciplinary isolation. And that's where we're at in America. I think the general reason is that we're pressured within academia to dispense knowledge that's needed by the wider society. And the general impression by the wider society is, and for that you don't need Greek or Latin. Tell us how to run this machine, run our business, and forget about the Latin and Greek. One reason for bringing up John Milton today is rarely, in most universities today, would anyone study John Milton. But it may be very important. What we've done is we've done that for the Bible too. It's old, so therefore it's got to be out of date, and therefore it doesn't apply. But that's a longer answer than maybe you wanted.
Okay, more questions? Yep.
Yes, you raised in your list of the enterprise in the 21st century the issue of moving from what is right to what is legal,
Yes.
and removing ethical and moral constraints. I don't know if we have any lawyers here, but you obviously know some lawyers, I know some lawyers, and did my daughter as a lawyer. If you went to the lawyer now and said, in the way you're allowed to operate and the way you do operate, where in what you do you take ethical and moral consideration into account, what do you think they might say? Oh, I mean, bearing in mind what you've just
Yeah.
argued.
Yeah. The ones that would be most empathetic to what I was saying would be the people who call themselves constitutional lawyers. Because what they do is they get to the root of the law. And the root of the law still is largely justice. And, but if you're consulting the divorce lawyer or the business lawyer, they'll get out the law book and say, this is what you may do, and this is what you may not do, and I think I can win this case on these grounds. And that's a legalism which we now use. I'll give you another example. I've written in the late 70s an article on the law of the sea as a matter of seabed justice. And I contacted one of my lawyer colleagues, a professor of law, a distinguished professor of international law at the University of Wisconsin, whom I called from Calvin College where I was doing this work. And he said, interesting, you're dealing with justice. We don't do that anymore. So it is really, I think it really is a real shift. I think too, we even now tend to specialize lawyers into the fields I was just saying. By contrast, Jewish lawyers, if they're Orthodox or fairly conservative, are quite different because the ones I know will spend with their colleagues a half a day every week studying the Torah. And I guess if I were going to get an attorney to represent me on a justice hearing, I would go for a conservative Jewish lawyer.
I know some.
So, provided I was right. If I were wrong, I'd avoid it.
I notice in what you said, of course, and as we all know, our lawyer friends still love to call everything by the name justice.
Yeah.
So have they not understood this shift, that in fact they're lawyers and not justice seekers?
You know, I don't think many of them do. When once in a while, I will meet a lawyer friend of mine and I'll say, oh, it's so fine to meet a jurist. And I'll say, what is that? I said, oh, a lawyer. Oh, yes, I'm a lawyer. Being a jurist and a lawyer is different because a lawyer, I mean, maybe technically people think of themselves as the same, but being a lawyer is you're a kind of a doctor of the law. A jurist, you're more in the category of being judgment oriented toward justice. And so when I look at these older contributors to the law, they're all referred to as jurists. And now only the judge is maybe considered to be the jurist, but the judge is coming through law to become the judge too. So I'm not, one of my tasks is to probe for causes and to stir up this discussion that Milton's talking about so that we can, in a very gentle way, raise some of these major issues and transform the society if needed.
There's a question at the back.
I have the misfortune many years ago having studied law and also having a theology degree behind me, but I'm toddler steps in both disciplines. But I would say, in defence of lawyers, and maybe you could say the same about doctors, that you go and see a doctor when you're ill or when there's a problem, and they're quite good at dealing with that side of things, so with conflict management and resolution, setting the minimum standards or dealing with the problems.
Sure.
The question with morality is we're looking for what is good, what is above the minimum threshold, but what is a good life, how should we live that, not what is our minimum duties to one another.
Yeah, right.
And I think that's a key distinction, and I think it's quite right that we distinguish between the role of law and, in a sense, the ideal, what we would like to see, the ethics, the ought, we ought to work at that, which should be a higher threshold than what can we get away with.
Sure.
And I think that's quite an important distinction to bear in mind.
Yeah, it is. It is. I think, I'm not slamming lawyers. I'm I am, though, raising the question of how we educate all of us, including lawyers. Because what we do is we have forsaken giving the course of moral philosophy for a long time now. Maybe there are exceptions. But it seems to me that the highest aspiration of someone's working with the law is really to seek justice. And perhaps even, as one of my colleagues who is a lawyer seeks to do, is to change the law to move it more in the direction of justice.
There's a question in the front.
You're quoting Jim McCarthy there in his congressional testimony, making some very strong claims against identifiable individuals. Did Exxon seek to sue him?
Oh, no, they didn't. But they immediately issued press releases refuting what he said. But when you then go on Google, about 3-4 weeks later, a lot of the think tanks they were supporting drop off their list.
Right.
And they are in a. In fact, there was a statement they just made that they said they were arrogant, insensitive, unjust. Exxon made that announcement to try to defuse some of this. What I wrote in my notes on that is, do works worthy of repentance. You know how all of us maybe have had experience with children who keep doing wrong things and then they keep saying, I'm sorry, I'm sorry, I'm sorry. And once this drove me to the scriptures, because I wondered what happens, you know, if you just keep saying you're sorry. And then I came across the text that say, do works worthy of repentance. In other words, when you're sorry, you do something about it. You don't just say, I'm sorry. So that's what I'm waiting from Exxon for, is works worthy of repentance. And what they did just do is to make sure that what they had been assessed to pay for the Exxon Valdez accident, the fine they were assessed would be substantially reduced. And that's maybe opposite of a work worthy of repentance. I don't want to get into trouble with Exxon, and my apologies to all the Exxon people who are listening to this. But it would be lovely if you get to the considerations of biblical justice, and also get back to seeing some of the things that Hugo Grotius has contributed to this whole field, which we now have violated severely by converting it into a world of what is legal. And through that, we have actually found ways to legally steal from the poor.
Maybe we've got time for one more before tea, right at the back.
Yes, we are talking about law and justice. Where does morality come in? After all, we are talking about science and religion. Where does morality come in?
Where does morality come in? Yeah.
It would probably be best answered by someone else who is here, but I'm not sure which one that is. I think justice sets the framework within which we operate as moral people, and I think morality is even a higher standard. I would turn you to the scriptures, and as a whole, it's not very kind, is it? But read the Bible. The thing that impresses me about the Bible is not only is it a handbook for how rightly to live on earth, ecologically, but it also is a handbook for how rightly to live on the earth morally and justly. And of course, it's much more than those two as well. Well, I thank you for your questions. They're very stimulating and helpful. And I'll see you again on tomorrow.
Yes.
Thank you.